Hi guys, am I audible? Can you hear me?
Um,
Okay, fine. So we'll just wait 2 minutes, let everyone join in, then we'll just start off with the session. Okay? Okay, everyone. So this today is the project presentation. So on Friday, you have been given with the project to showcase. So today you have to share your project up here, like present your project up. So hopefully all of your projects are done, like you have all done with preparing your project. So one by one, you need to prepare. So I'll just raise your hand who are ready with the project. Guys, just raise your hands who are done with your project. Shireen Khan, okay. Krishna Chaudhary. Anyone else? Others? Guys, what happened? Okay. Cheers. He is also done. Next. Among all of you, I have got only 3 people who are ready with the project. What about others, guys? Haven't you worked on your project or what? Okay. Fine. Just a moment. Let me just write down you people's names so you'll be presenting. Okay. Okay, fine. So, Shireen, you are ready? Shireen Khan, you are ready with your project?
Yes, ma'am.
Okay. So, kindly share your screen and show the project. Others just, everyone just raise down your hand and Shireen, start with your presentation.
Ma'am, can you please tell me how to share with the help of share option?
Yes, yes, of course. Go down to share option, then you get an option of share screen. Just click it down and you'll be sharing like this. This is how you have to share it. Okay. I have stopped my sharing. You can start.
It
Yes,
is
it
visible.
is visible. Yes, yes, it is visible.
Okay, ma'am. 1 second. Yes.
Yes.
So this is my EDA project. Hello everyone, myself Shireen Khan, and this is my EDA project. And the title of the project is Disease Outbreak Analysis of COVID-19. So I am just analysis of COVID-19 disease. So I want to tell you that I want that I could perform the data analysis on a time series based data, but when I find the data set, so I could not find a accurate time series data. So I just take a 1 day analysis. It means the data is about 1 day, and the in this data I have 4,000 rows. So the domain is medical science, and the data source is Johns Hopkins WHO GitHub profile. So I just download my data set from from this GitHub. Then I also mentioned about the data set. So this is the data set. So it in this data set I have 14 columns, and this is the you know detail about the columns. So now I am starting. So firstly, I will load my data set. So I just import some necessary libraries like pandas, numpy, matplotlib, and seaborn for visualization, and warnings to import the warnings. Now I am just Now I am loading my dataset into with the help of pd.readcsv function, which is a function of pandas, and I am giving the path. I am giving the path of my dataset, and I am storing it into a data frame. Now I am printing the columns and rows number in my dataset with the help of df.shape function. So the zeroth index will be defined 411 rows, and the 1th index will tells us the column number. So we have 14 columns. Now I am checking the information of my data set with the help of df.info function. So when I analysis it, so I just see that the last update column is not in correct format, it is in object format. So I have to change it into a date time format. So I will convert it later. Now I just drop some unnecessary columns, which is FIPS and admit 2. So when I study about these columns, so these columns can't fill randomly. So I just dropping it, because if I will remove the null value, so I could lose so many data. So I am just dropping and it will not contribute in my analysis. So I am dropping it. So after dropping, I have 12 columns remain. Now I am just printing my data frame. So it will looks like with the help of df.head function, and I am taking upper 5 rows. Now I am checking the description of my data set with the help of df.describe. So it will describe all the statistical measure like count, mean, median, and so on. Now I am checking the null value. So I am using df dot is null dot sum. So it will give me all the sum of missing values in each column. So you can see we have so many missing values. So we have to handle it. So now I am checking the duplicate value. So we have zero duplicate value. Now we are handling the missing values. So first column is province state. So it is a categorical column. So I am filling it with the help of forward filling and backward filling method. So it will be good for our data consistency. So I am just filling it with the help of forward and backward filling with the help of dot fill na function. And the method is ffil means forward filling, and bfill means backward filling. So after filling it, I have zero null values. Now the second column is latitude column and longitude column. So these two columns are geographical columns. So I am filling it with the help of again forward filling, but I am using group by function. So what it will do, it will group by our data frame with the help by these two columns, province, state, and country region by latitude. And then I am performing transformer. So it will take um, all null values one by one, and it will perform x dot fill n. So x is the number of our missing values. So it will fill all the null values with the help of forward filling method. And now this I am filling my null values in longitude column. After it, I am just filling it in incident rate. So in incident rate, it is a numeric column. So I can fill it with the help of mean or median, but I am using median because it is more robust to the outlier. So what I am doing, I am just extracting the median value with the help of dot median. So I am taking my data frame, the column name, and performing dot median function. And the value I am storing it mid value variable. And then I am performing the dot fill na function and giving my mid value in this column to filling the uh, null values with the help of forward mid value. One second. हाँ मैम क्या प्रॉब्लम हो गई इसमें now I am filling my case fatality ratio. So the case fatality ratio uh, is death upon confirmed multiplied by 100. So it is the formula to fill the case fatality ratio. So when I am using this formula, uh, so I pay attention on this formula, and I saw that if our confirmed value will be 0, so the case fatality ratio will be infinite. So I am just handling it. So what I am doing, I am just taking the zeroth values in our confirmed column and converting it into a data frame, and again I am storing it into a zero convert variable. And when I check the rows of the and
Someone's mic is on, I guess. Guys, don't interrupt in between. The presentation is going on. If you like, if anyone is presenting, don't just like unmute yourself. There is some of the background noise that can like impact on the presentation, right? So don't do this. Yeah, Shireen, you can continue.
So I am taking the all zeros values, and then I have 55 rows in which zero confirm values are present. So I am just dropping it, taking only not zero value. So I am taking df confirm not equal to 0. It means the value which is not equal to 0. And again I am storing it into my original data frame. Now I am filling all the case fatality ratio missing values with the help of these formula. So I am just using df.loc function. So it will find out the location of the missing values in these column. So I am just using .loc function. So I am just using this formula and filling my missing values in this column. And after filling all the missing values, I have 0 null values, but I still have 13 and 16 null values in my latitude and longitude column. And I really don't know what problems is occurring. So I am just dropping it with I am just filling it with the help of forward filling. And now I have 0 null values in all the columns. Now I am converting my last update column in a date time format. So I am using a pandas function pd.toDateTime. So it will convert our last update column into a date time format. And also I am using errors equal to course. It means the all errors will be removed and it will not give any error. So you can see that our last update column is successfully converted into date time format. Now I am performing feature engineering. So I extracted some features like recovery rate, closed cases, latitude region, and longitude region. So the latitude and longitude region have some range like -90 to +90, and on the basis of these range divide the we can divide our countries into these groups like far south south. So if our latitude value is -90 to -30, so it will convert it into far south like this. So after performing feature engineering, we have these columns like latitude region, longitude region, closed cases. So I am using df.sample. So it will randomly take 5 values and it will print out. Now I am performing data analysis and visualization. For this, I also used Matplotlib and Seaborn, and also I am using Plotly. So first I am using Matplotlib and Seaborn. So first I will group by province state by confirm, and I am taking all the confirmed values with the help of dot sum function and then sorting it. It means I am taking top 10 values. So ascending equal to false means it will give the values in descending order, and dot head 10, it means it will give upper 10 values. So you can see that these are top stats. Now I am just visualizing it with the help of Matplotlib and Seaborn. So I am using SNS dot bar plot, and this is the x and y variable. And x rotation equal to vertical, it means the label on x axis will be present in vertical format. So you can see that it is in vertical format. Now I am visualizing top 10 province state again with the help of these code. And this is the top 10 province state with death cases. Now I am visualizing top 5 countries with confirmed cases, and these are the top 5 countries. But to visualize it, I am using Plotly. So I just work on Plotly and I get some information. So I am using the bar plot, and then I am giving my data frame and the label of X and Y, title, colors, and labels. And this is the top 10 countries. Like this, I am printing top countries with high deaths. So in US, Brazil, India, these are the top countries with high deaths. And for this, I am using a tree map graph. So what it will do, path equal to country region, it means it will group by with country region, and values equal to death. It means the size of these squares and rectangles are based on deaths. So like this, I am printing it and I am visualizing it. And these are the top 5 countries with active cases. And these are the top 5 countries by active cases. So I am just using Plotly. And then I display only two decimal places. So I was printing top 5 countries by incident rate, but it messed up because the number is too high in incident rate after decimal. So I am just taking two decimal places with the help of these function. So I am using these function dot round. So it will take only two decimal places, and after it our data will looks like. And now I am visualizing it like this. So I am using pie chart because pie chart is a good fit for a percentage type data or the um, rate type data. So in US we have top rate. So now I am display only two decimal places in case fatality ratio. Again, I am writing this code, and then I am visualizing top 5 countries by recovery rate. So it will looks better. And the top countries by case fatality ratio. So these are the top 5 countries by case fatality ratio. And like this, top stats by closed cases. It means recovery plus deaths equal to closed cases. And then it is the data distribution along the latitude region. So you can see in north, equator, south, far north, and far south. And this is the recovery rate in latitude region. And this is my end of the project. Okay, thank you, ma'am.
Okay, got it. Just go to the top section of your code. I asked you to share your screen and go up in the top section of your project, like the inner collab file.
Okay, ma'am, one second.
Okay. So you have taken the disease outbreak analysis of COVID-19.
Yes, ma'am.
So can you just show me the data set? Okay,
Okay.
not okay, no need, no need. Just go down. I guess you have viewed it. So there from there also I can see.
Yes, yes, yes.
Okay. So you have got province, state. So the state is most of the case it is empty.
Yes, ma'am. It have too many null values.
Okay, got it. Then we have this country region, last update, latitude,
Yes.
longitude, confirmed, like the confirmed means COVID positive confirmed, right?
Yes, yes, ma'am. Yes.
Okay, death, recovered,
Recovered.
active cases, combined key, what actually it is?
This is a combination of province, state, country, region, and the admin too, which I already drop out.
Okay, it contains what it contains, combined key, what it contains?
Exit. Okay. I'm just showing you. You can see here. Hmm. Like this. So it
Okay,
contain yes, province, state, admin
okay,
too, and country, region.
okay. The state you are getting from here, right?
Hmm.
Okay,
Yes, ma'am.
okay. Go up now, go up. Okay, fine. Now, okay, okay. To the sections, yes, yes. There itself, incident rate and case fatality ratio, right?
Yes,
So
ma'am.
this
Yes.
is your project, fine.
Hmm.
Just go down to the, I need to check where you did the pre-processing section once.
Okay, okay. I think from here.
Okay, fine. Just a minute, just a minute. The null state, I did, let me check the null.
One second.
Yes. The null you have got, right? Yes, the missing values actually.
Hmm.
So
Hmm.
you have got 178. So what is the shape actually? What is the number of rows and columns?
4011 rows and 12 columns.
Okay, fine, got it. So in that 178 is missing, right?
Yes,
Okay,
yes.
got it. Latitude missing, longitude missing, incident rate, and case fatality ratio. So
Fertility ratio.
combined, okay. So combined key, from combined key, you can get the province state. Like the third, like it is separated from comma. The third one already like gives the province state, right?
Actually, ma'am, these all columns are already present and the combined की ज्यादा यूज में आया भी नहीं था और मैं शायद इसको ड्रॉप करना भूल गई थी क्योंकि कंबाइंड की से मैं एडमिन टू वाला जो कॉलम है वो एक्सट्रैक्ट कर सकती थी बट आई थिंक उसमें थोड़ा बहुत नॉलेज की जरूरत थी मुझे समझ नहीं आ रहा था उसमें
Fine, but combined key does contain like the way you have shared me. So I guess it contains three values, right?
यस
In
यस
combined key, the last value is of province state, right?
यस यस
Okay, so I guess from here you could have taken into the province state and this 178 values, like the missing values can be handled over here,
but I am filling
right?
it with the help of yes, but I am filling it with the help of forward filling and backward filling.
I understand forward feeling and backward feeling, you are feeling it, but the data won't be correct. Like the exact data you won't be getting, right?
यस आई कैन अंडरस्टैंड मैम एंड आई थिंक आई मिस्ड अप एंड ये चीज मुझे ध्यान रखनी थी कि मैं कंबाइंड की के थ्रू प्रोविंस स्टेट को फिल करती अदरवाइज ये
Yes.
रॉन्ग हो रहा है अभी थोड़ा
Actually, yes.
हम्म
So,
हम्म
just make a note to just do it that from combined key state, you can fill this province state for
ओके
178 data. So, if you're
हम्म
doing it, so this becomes null. Now, you have missing values for latitude and longitude, also with
हम्म
the incident rate and the
एंड
fatality
कैश
ratio,
पेटेंट यस
right? Okay.
हम्म
So, now give me the data types for all of the columns.
दिस इज द डेटा टाइप
Okay, fine. Okay, province, state, object. Latitude is float, longitude is float. So this is numeric value only. So you can
यस
just take down for that 89 or some values were missing, that you can take it like mix it up, fill the value with the mean value of all.
मैम एक्चुअली मुझे इस बारे में ना समझ में आ भी नहीं रहा था कि हाउ आई फिल द latitude and longitude column. So when I search about it, so I just fill it with the help of forward filling क्योंकि latitude, longitude, it is a geographical feature, you know, so
I
it is
got it,
special.
but
Yes. Hmm.
I got it, but the thing is, majoritarily, latitude and longitude won't take much of the efforts here in your project, because that is
Okay.
latitude and longitude. But based on that, no one remembers any of the country or state latitude and longitude wise. That is an information that has been given. Right, just
Okay.
filling it backward and forward. What it does, the forward data that you are getting, you are filling it up in that very cell, right, or in that very position or in the data frame, right? So if you are doing it like that, so you are misinterpreting any of the sections,
Okay. Okay,
right?
ma'am. Okay, I
Okay,
got it.
so it
Hmm.
can be done in any of the section where we can take it like any of the format where the datas are quite identical, or we have two type of categorical data, like category wise, like suppose one and two or one, two, three, this kind of data we are having. Then we use forward backward feeling that
Okay. Okay.
like we can just take it in that form. Okay,
Yes. Yes.
so now go down with the like this is the part that needs to be taken care, and other stuff. Okay, fine. Let's go down to the plots that you have done for EDA. Okay, fine. Okay, so what it is? Top states you are getting. Along with that, what is that? Confirm, like confirm cases, right? Okay, got it. Fine.
Yes. Hmm.
Okay. Fine. Just then you have a state name that is unknown.
Yes. Yes.
Okay,
Yes.
fine. That is there in your data set, right? Okay,
Hmm.
fine.
Hmm.
Move it down. Move it down. Fine. Top 10 provinces with confirmed cases. Fine. Move it down. Okay. For a change, just don't include the charts over here. Just go up. This charts, this is basically you have given the chart for province state along with the dates, so that
Yes.
one can easily get from the like from the sheet from the data frame that we are creating. So no need to just put it in the tabular format. It's not required. You can directly change it to the plot. Fine,
Okay. Okay.
just go down to the plot. Okay, this is the top 10 based on the provinces. Fine, move it down. Two plots down, right? Okay, fine. Just move down. I just need to see the plots.
I used
Okay,
Plotly for this graph.
okay. Top 10 with confirmed cases. Okay.
Actually,
So
these
previous,
is top five.
okay.
Mm-hmm.
Okay, one, two, three, four, five. Yes, but here you have mentioned top 10,
Yeah.
so that
Yeah.
you need to change.
Mm-hmm.
Okay. So can you just put your cursor up with USA bar?
US.
No,
Okay.
no.
Okay. 1 second. Ha. Okay.
Okay, fine. You are getting around
2 crore something like
two
this.
crore, yes, yes, 2 crore
Hmm.
data, like confirmed cases you're getting. Fine. Just move it down. So this is the third plot down. Now move it
Yes.
down.
Top countries with high dates.
Okay,
It,
fine. So
yes.
dates and countries you already did, right? What
No, ma'am.
like in the
It was
date in the second column, the second chart that you have prepared?
about state and it is about
Okay, okay,
countries.
okay. Region. Okay, fine. Fine.
Hmm.
Understood. Just move it down. Okay, but just a moment. Here, what type of plot you are using? Just
I
go
am
up.
using, yes, I am using a tree map.
Tree map. Okay, got it. But this doesn't give any of the proper insight. You can use a column chart or any of the bar chart or even also the pie chart that would give a
Yeah.
better insight.
Actually, ma'am, I am working on Plotly, so I don't have any too much knowledge about it. So I just
I
plot it so
understand
for yes.
tree
Hmm.
map. There in that place, you need to put any of the chart name, either bar chart or like that. You need to put it and accordingly give the like the title and stuff. The similar way have you put, like the way you have put it in the similar way only. Okay. Just change this one because this doesn't give a proper insight over the tree map, doesn't give a proper insight. Change it to any of the other plots. Maybe pie chart would do good with the
Okay.
percentage in. Okay.
Okay, ma'am.
Just
Okay.
move it down, move it down, move it down, move it down. Okay. Okay. Fine. So active cases, but here you have got this is coming in. Okay, fine. Based on the rate you have, like the color based you have taken it.
Yes.
Okay, but okay, fine. Keep it like that because here there is we can't segregate based on the colors. The colors are too close to be taken into. Okay, you can also remove the colors, just use different colors for the plots. And you, as you are using plotly, when you anyone will put, like use it in a form that when anyone will put the cursor on, they will get the exact data. So
Okay,
I
ma'am.
guess then you don't need to use this active case, the color scheme you don't have to need. You don't have a need on that. Just move down, down, down. Oh, yes. Okay. So top countries with incident rates. Okay, got it. USA is more. Fine.
Yes.
Okay. Put it down. Okay. Recovery rate. Got it.
Hmm.
Now move it down. Okay. Go a bit down. More. Yes. Okay. Top stat with closed cases. Fine. Okay. Got it. Fine. Move down. Okay. Fine. This also changed this part, rate in
Yes, yes,
latitude
yes.
region.
Hmm.
So you don't need to include the latitude region because longitude, latitude doesn't make any of the proper
Yes,
change
yes,
over.
yes. Hmm.
So you can take a change over here. That's not required. And just go up a bit where you have plotted based on like the bar graphs, I guess, with multiple colors.
One
Up,
second.
up. Yes, it's this one, right? This one.
I'm giving color
Just
by closed cases.
yes, yes, closed cases.
Um.
Okay, yes.
Hmm.
So here you can see where you have given the colors, right? So here, since the numbers are with that range only, like 3.2 million to 3 million, 2.8 million, in this range only. So it is like making us understand that we are getting like the color scheme is well used. But in the
Yes.
above,
Hmm.
another plot that you did, the number schemes were so like close to each other that it is giving the same color up. So not getting more of the insight from that. The color scheme is not using up in that format,
Okay.
right?
Hmm.
Okay. So this is all about you can do some this of the necessary changes and then you can just submit your project in the mail ID. Okay.
Okay. Actually, ma'am, I submitted my project. So now what I do?
Okay, so you do all of this necessary changes, and
Okay.
in the same mail, just forward just reply it over and say and ask this is my updated version of the project.
Okay, ma'am.
Kindly accept it and share it like that. Uh, just give your GitHub account link, like the GitHub repository
Yes,
link for
yes, I
this
have.
project.
Hmm. Hmm.
Okay, along with that, share the collab file along with that. Okay.
Okay, ma'am. Okay, okay.
Okay, attach the collab file actually. Fine.
Okay, ma'am. Hmm.
Okay, yeah. And Shireen, I am just sharing a Google form link. You need to just fill that up because this is for those who are actually presenting in today's session to keep a track on. We are using that. So you have to just fill that part on.
Okay, ma'am. Okay. I will fill the
Okay.
form. Hmm.
Okay, fine. You can stop sharing. Chira, sorry for interruption, but I am at the university and my department. Yes, who is saying?
Hello?
Yes. Yeah, who is saying?
Don't know.
Yeah, Shireen, any query?
No, ma'am,
Else
no, ma'am.
you can stop sharing and mute yourself.
Okay, okay.
Chiras, yeah, if you can present it now, you can definitely present it now. Shireen is done, you can present it. You want to, yeah.
Are you watching?
Sorry?
Sorry, it's my first time explaining a project in English, so my English is not so good.
Okay, then, okay, just try and go ahead so that I can at least understand about it.
Yeah, I'm
Okay.
trying to explain and understand you what you speak. Sorry.
Sorry, Chiraz, I am literally unable to understand what you are speaking on, but I'll try my from my end. But you go ahead and explain each of the stuff as Shireen has spoken in the same way you have to present it. Okay?
I'm trying write my explain in message for you understand me for the clients.
Okay.
But I'm
You speak any other language like any of the understandable language like Hindi or stuff?
uh, French is not well. I don't
Uh,
know,
can
understand
you
Arabic.
just write it down in the chat? I am literally not understanding what you are saying. Anyone can understand her? Can you just help me to understand what she is saying? Anyone can understand what she is telling?
No, ma'am.
Okay.
Second,
Chiraz,
I'm trying. I write a message for you understand me what I do.
what you do? Okay, you write a message. I got it. Fine. Just drop it down in the text. I am seeing it and reverting you back.
And
I want to say I'll try to explain and write here. So that you may understand me a little. Okay, got it. Fine, you start with your presentation, but I don't know how, without like how I'll be understanding, and it will take time, right, to just write it down and to explain how we will be communicating. Okay, fine.
um,
You start off. You start off. Let me see how I can see it. If it is understandable, we'll keep it. Else, we'll try and find any other way to take down your presentation.
okay, no problem.
Ma'am.
First, I import the libraries, the pandas, NumPy, Matplotlib, Seaborn for analyze my data set. Then I read the reset, the cybersecurity attacks. I give it this for Kaggle. Then I use the F hat for explain my columns like timestamps, source IP, source port here. When I do a describe for now substacks numeric like count, main, std, max 25%. I don't understand me what I speak or no.
Yeah, continue, Chiraz. I'm trying to understand. You go ahead.
Okay. Then I use the F shape for know how columns and row in my data set. Then uh, I I do the data clean and coding. Here check my missing value for here my data set. When I do that, I see 1, 2, 3, 4, 5, 6 columns. It's here missing value for 70% missing value. For that, I want to clean that. I given the df drop for clean the data set for the missing value. Here I'm using the label encoder, sorry, the F info. I think I estimate that false. Here live encoder, I use that for transform the variable for object to numerical for visualization before. When I do visualization, the first visualization is the type, a text type. Here, the two types attack and the count for them. Then I show the secret maps for three classes: low, medium, high. I do that for know what's the type, what's the active type. Here DDoS or malware or intrusion. For when I do the shots, I know it like that. Then I use the bar plot for attack type and the security level and me. Here I do the average security per attack type and the level of security for each one. Then I do the count plot for attack type by the count like this. I understand me. I think I don't know.
Yes, I'm understanding you. You go ahead.
Thank you. Then I show the script plot for packet length and anomaly score and act type and choose there. Uh, and here I do the count plot for protocol and attack type, and he showed me that here for the column of timestamp, I change the format the date time, and the I show the line charts for I can read that column.
Okay, you are done.
That's for this. This my first project, and I don't know what exactly I do for this data, but I do what I understand for this data.
Fine. Just go ahead, share me the data set, like where you have viewed the data that you show me. What are the columns you are having? Go down. A bit down. Yes. So you have just up. I just need to see the column names. Timestamps. Source. Just go slow. Uh, okay. Timestamp was there. Just move it a bit left. Yes. Source IP address. Then destination IP address. Source
Yeah.
port. Destination port. Okay, fine, got it. And based on the one, you have taken which project in? Like this is related to the attack, malware attacks.
Yeah.
Fine, go down. More. Okay, you have taken 40,000 with 25. Fine. So how you handle this number of missing datas, like missing values, how you handled?
For the drop, I think I
What?
can't answer you. I can't understand you.
Okay, you can't understand me. Like here you have
Yeah.
proxy information. There are around 19,851. Along
Yeah.
going where malware indicators, there were 20,000 datas. Next, alert warnings, there is around 20,000 and 67 datas. So these are missing datas, right? So how you
Yeah.
handle those datas? Like, did you dropped off all the columns or what?
Yeah, I dropped the columns each missing value like malware. I dropped that. Alexis, I dropped that. I
So
get
that's why you have
just
got the plots like that. So you don't have to like, you need to see what exactly is, are you getting any proper idea over that, or is it unrelevant over your data set? If it is unrelevant, then only you have to drop it off. Just by seeing that you have missing values, you have to drop off. That is not the solution.
hmm.
Move down, and based on that, why haven't you used plotly in any of the charts? And the charts that you have prepared, they're more cluttered, and the datas are not getting like equal type of datas, like the range for which you have viewed it, that is not varied. Like it is segregating in one or two or three columns only, it is not segregated out. So that is the major thing, that these things you need to change over. Then you need to upload your project in your GitHub, and then you have to submit it in the mail ID.
Okay.
Okay. Fine,
Okay.
you just change all of these things. Use different types of, like, since there are 20 columns you're having, see what are the useful columns that you can play with. Like, play with means you can work with actually. Like, you can just explode those columns in that form I am saying. So, based on that, go ahead for the visualization. Your project is becoming like the way you have taken it, so it is segregated on a single area only. That is not widely spread over the entire data set that you have taken in.
Okay. I understand.
Okay, fine, great. So you can stop sharing as of now, do the necessary changes that I have suggested. Then only once that is done, then only submit your project, okay, in the mail ID. But as of now, just I have shared a Google form link. Go ahead and fill that form up. Okay, Chiraz?
Okay.
Okay, fine. Next, Krishna, you are here?
Yes, ma'am.
Yeah, Krishna, can you just present your project?
Yes, ma'am. Wait a minute.
Sure, sure.
Is my screen visible, ma'am?
Yes, it is visible.
So my project name is Bank Loan Approval Pattern Analysis. In this analysis, our goal is to analyze how various financial and personal factors affect the probability of loan being approved. So in this, I have downloaded this dataset from Kaggle. Then now we start with the analysis. So this is how I mounted the drive. For data wrangling, This is first 5 rows. Now, yeah, this data set was actually good. It didn't add any missing values or anything. I tried 2 or 3 data sets, but every data set had zero missing values. I don't know how. So I did analysis on this data set only. Then further, these are the data types and all using D types. And I am using a copy file, of course. Then this is a loan to income ratio. That is a certain person is applying for loan against his income. Then I have created bin files. That is I have divided number into bins using pd.cut, so I can categorize them further. Then this is just a describe function, as you can see. Uh, Now in the EDA process, data was much clean before, so I didn't need to do any much pre-processing on it. So we can move directly to EDA. Now we have made first plot is loan approval distribution. So here we can see about 60 to 65% loans are approved. So database is good. It is valid only. Not all requests are approved or rejected. Fine. Next, we will be seeing loan approval rate by gender. To be honest, gender will not impact on approval. So we can see here data set is actually gender neutral. Okay. Then loan approval rate by credit score category. So here also I have used pd.cut to create bins. Uh, our credit code score is 0 to 1000. So I have made categories to 0 to 300, 580, 670. So good, poor, fair, good, very good, and excellent categories. I don't know how in this data set, but it was surprisingly credit score was not making any correlation with the approval. So every category had nearly same 20 to 25% approval rate. Further, we are seeing impact of various loan approval on loan defaults and approval. So if any certain person will have any previous default or anything, how will it impact on the loan approval? So here, people with no default rejected, it is roughly balanced actually, and the people who don't have any previous default, they have high approval chances. So here, blue bar is dominating. Then this is income versus loan amount relationship. So in our data set, most applicant uh, earn less than 1000K or something, and they are taking smaller loans. And we can see many have higher income also, but that doesn't guarantee them approving their loan. That is, other factors are also impacting on this approval. After that, I have made a heat map also. It have various factors, and how are them correlating with each other. In this, we can see like percentage and what is person experience is. Okay, so age and experience can relate with each other. It's basic. So this is the heat map, and finally conclusion. This is a heat map's summary. see multiple factors correlating with each other and all. My conclusion was loan approval depends most on loan amount related to income and previous default history, not just income and credit score. I don't know why credit score was not relating or correlating with it. It was in the database only. People with stable income and moderate role request clean credit record get approved more easily. Thank you.
Okay, Krishna, just go up with the data. I just need to view it. Okay. This contains age, gender, education, income, along with the experience, is it?
Yes, it is work experience.
Okay, fine. Experience, then the home ownership.
Loan
Okay,
amount,
loan amount, intent. Okay, then is the rate, percent income, along with that, credit history length, credit score, and previous loan default on file. And the last one is
loan
loan
status.
status.
Is it approved or not?
Fine, got it. Fine. This is the raw data, right?
Yes, ma'am.
Fine. So to now go down, you check for the missing one. So you haven't got any missing value?
Yes, ma'am. I
Okay,
tried
fine.
2 or 3 database, but none of them had a
Okay, fine, got it. Move it down.
missing valuation. This is the
Okay. Types, data types. Fine. Okay. Move it down. Okay,
made
so
bills.
the here you are just doing columns for bid. Okay, you are changing it to the labels, right?
Yeah.
These are the pre-processing step you are doing, like the
Yes, ma'am.
inside, basically engineering, like you're adding some of the columns, right?
Yes, sir.
Oh, okay, okay, I got it. I got it. Fine. Okay, fine. Okay, move it down.
This is again
Oh,
the category I made, so I can show it here.
okay, fine.
This is a ratio also.
Okay,
Now EDA. The
okay.
slot
Loan
is
approval. Okay, go down. So approval is more, rejected is less. Fine. Move out. Okay, gender is equal. Fine. Move down.
this was
Credit code.
credit score. Yes.
Okay, fine. Move down. Okay. Yes or no? So why this is okay? Impact of previous loan default on approval. Okay. Zero. That is that has no impact. And this is so why this is like this? Okay. No. Okay. I got it. Fine. I got it. Fine. Okay. Move it down. Fine. Applicant income versus loan amount. Fine.
It's like a 100K to 100K, 300K category or range, we can
Oh,
say. So
so these are Ks, like 1K, 2K, like that. Okay, okay, I got it. The here is the income and the amount, but income you have put as 1, 2, 3, 4. So this is not
yes, ma'am.
match. That is not matching. So you need to at least put K over here so that we can understand that stuff. Like it is 1K, 2K, or the exact amount.
Okay, okay, ma'am. I will update that.
Okay, go down.
Ma'am.
Yes, the correlation heat map.
Yes, ma'am.
Fine. Okay, so it is for each of all of it, right? All of the columns that you are having.
Yes, ma'am.
Okay. 10 columns you're having, right? Okay. What
Yes,
is the shape 10 column and how many rows?
uh, again, can you repeat, ma'am?
So what is the shape of your data set? Like how many rows are there and how columns are 10, but what is the number of rows?
There were like 45,000 rows.
Okay, got it. Fine. See, the very first thing that I have seen that you could have taken the like the pre-processing section to a more, or you could have add any of the rows, any other rows also based on this columns that you are having. If not, also you could have used the Plotly Express for getting interactive plots. So most of the plots are like bar graphs only. So there are no other changes that we are getting to see. Like you are just comparing based on the bar graphs that I
Yes,
could
yes,
assumed. And one, I have got the heat map. So there should be variety in the plots also so that it's easily comparable.
yes, ma'am.
So last time I have shown you the Plotly Express. There I have included four categories under a single chart, right? So I am not asking to do that, but you could have used Plotly so that it makes interactive and better to look at also and looks professional also. And you
Okay,
could have include more visuals to get better insight over that.
okay. I will update that.
Okay, fine. Okay, Krishna. Fine. You can do that. And as of now, just share, like fill the Google form that is there in the chat and do the updation and then share it in the GitHub and share it in the mail ID that is mini underscore project. That mail ID you need to share your project with your collab file along with the GitHub repository link. And do mention this is week one and what is the title of your project. Do mention that, then only submit.
Yes, ma'am.
Okay, fine.
Thank you.
You can stop sharing. Okay. Okay, Ahana. So will you be able to present it now?
Ma'am, can I share?
Yeah, sure,
I
sure.
am
You can share. Fine. You
I
can
am Maz,
share.
ma'am.
Yes, yes, I understood. It's okay. You can share.
Okay.
She is actually not replying. It's okay. You can share.
Is my screen visible, ma'am?
Yes, your screen is visible.
So hello everyone, my name is Maz and the project name is that we have to do exploratory data analysis on disease diagnosis dataset and its domain is medical science. So our first step is to know the problem statement. So the problem statement is that we have to perform EDA on this disease diagnosis dataset, and the goal is here to process the data, handle missing values, and explore relationship between different column features to understand about the disease and how to predict them. Then let's jump to coding section where we first import necessary libraries. So first we import pandas, then NumPy, then there are three import matplotlib, seaborn, and plotly for visualization. And we also import a min max scaler for normalization. Yeah. Then comes the first step to load the data set, and I, I have loaded the data set, and the data set first look like this, where we have approx 2000 rows and 13 columns, where you can see that we have patient ID, age, then comes gender, then there are three symptoms, and then comes signals such as heart rate, body temperature, blood pressure, oxygen saturation, and then comes diagnosis, whether it has any disease or not. Then the severity, if it has disease, then how severe it is. and then the treatment plan, what we have to give them on the basis of disease severity. Then the next step, third step is to know about the data set. As I had already told that number of rows are 2000 and number of columns are 13. Then comes data set information, which for which we can put dot info. So basically it told about how many counts of data in each columns and whether there is null data or not, and the data types. So you can see numerical data types are 5, one is float and 4 are integer based, and remaining 8 are object data type. Then comes step 5, which is to check whether there are missing values and or not. So in this data set, it is cleaned already, so there was no data and no missing values found. Then comes a visualization, but as I have already told you, there is no missing value, so you can see 0, 0, 0 in the chart. Then comes understanding your variables, which I have already told you about the columns, that is patient ID, age, gender, symptom 1, 2, 3, and then signals, and then the diagnosis, severity, treatment plans. And I have already told about the data types already and the above. Then comes data set description. Basically, it is used for numerical columns only, for which we use dot describe. So basically what it tell you that in numerical column, it first tell counts how many rows are there with values. Then the second thing is mean, the mean value. You can see average age, mean age is 48. Then comes standard deviation, how much our data deviate. It's mean 48 plus 17 and 48 minus 17 values are there in the data set. And the minimum which we find in the age is 18, and then comes a percentile, 25 percentile of data lie below 33, then 50 percentile 49, and then 75 percentile at 63, and the maximum value which is found of age is 79. Then another step is to check unique values in each of the columns. As you have seen that patient ID has unique values 2000 because has the unique values patient ID. Then comes age, unique values is 62. Gender are 2 because of male and female. Then symptoms 1, 2, 3 each has 8 unique value counts. Then there are numerical values whose unique values are given there. That is 60, 46, you can see. Then comes severity diagnosis. So there are 5 diagnoses. One is healthy and other 4 are diseases. Then comes severity, where there are 3 cases. So you can see there is a unique value count is 3 because mild, severe, and moderate. And there are 3 treatment plan. Then comes step 10, where I have provided variables descriptions, which I have already told you earlier. Patient ID, age, which lie between 18 to 79, then gender, which is male, female, and then symptom 1 is primary symptom, and symptom 2 is secondary, and symptom 3 is tertiary. And you can see first census data are vital signs. Census data are heart rate, which range between 60 to 119, body temperature, which lie between 36 to 37.5, and blood pressure. As for normal blood pressure for systolic and diastolic is 120/80. And then comes oxygen saturation level, which tells about how much oxygen is carried by hemoglobin. Then the diagnosis, which I have already told you: healthy, cold, flu, bronchitis, and pneumonia. One is healthy and other 4 are diseases. Then the severity level, and last treatment plan. Then comes data wrangling step, where we first check about the duplicate rows. Is there any duplicate rows? But the data set is good, so we can't find any duplicate rows. Then comes fix inconsistent entries, in which we just see whether there are spaces or not in the string data. So we remove spaces, unnecessary spaces. Then comes handle missing values, but here is no missing values, but the concept is that for numerical values we use median to fill the gap if we find missing values in numerical columns, and for categorical we use mode, such like if there is missing values in diagnosis or severity, we will use the mode. Then then comes the step of detecting and treating outliers, and basically it uses 5 number summary, where which we have Q1 that is 25 percentile, Q3 that is 75 percentile, then comes median and minimum and maximum. So by using the formula we have treated the outliers, and if some outliers is and we remove outliers with the help of median values. Then comes the next step, which is normalizing each numerical column. So our model will not be biased. For that purpose, I have used mean max scaler, which basically range each value of each numerical column value between 0 to 1. So as you can see, age has come across 0 to 1 value and all other numerical columns. Then comes the encoding part, where we encode each categorical feature because we have to give some models in numerical form. So for this purpose, we have also encoded, and you can see that the gender, which is present as a single column, now is split into 2 columns separately, gender male, and there is present gender male, and it has true. If the gender is male, then it's true, and if it's not, then false. So it's basically divided into many number of columns. Initially there are 13 columns, now we have 38 columns. Then comes some feature engineering, where what we do, that earlier the blood pressure, systolic and diastolic, is given in a same column. It is, let me show you. Here you can see that blood pressure and systolic and diastolic is given in a same column. So I separate it into systole and diastole.
Can you show it once? I can't get it, like the
Yes, ma'am.
systolic and diastolic section.
So basically, ma'am, in blood pressure, there are two things, that is systole and diastole, as you already know.
Okay.
But in this column,
Yeah.
blood pressure, it is separated by slash. So it cannot be given to the model directly. So I split that blood pressure
Okay.
columns and make it two separate columns.
Okay,
So
fine.
that
One is systole and another is
there
diastole.
is
Fine.
diastole. The first one is systole, that is 132, and other
Yes,
is,
yes, that's understandable. Okay,
yes,
got
ma'am.
it.
So in future engineering, I have done that.
Okay, fine.
And also I have categorized each age group, such as I have created bins, that is 0 to 25 is taken as young, then 25 to 40 middle age, 40 to 55 seniors, and 55 to 100 elderly. And similarly, I have split temperature also to make it categorical, then heart rates. Similarly, I have done for oxygen also, and then some critical vitals to see if the heart rates is greater than 100, then you can see that vital count is 1. So you can see that the chances of any disease is how much. So you can see now that we have systolic blood pressure and diastolic blood pressure, and the age group is now elderly, and it has become categorical now. So now the main parts come. I have done my pre-processing step. Now comes the exploratory data analysis part, for which first I have do univariate analysis, in which we take only one column. So the first diagram is about age distribution, and you can see that mean median values is approx 48.3, means in data set average mean value is of age is 48.3. and its range between 33 to 63. Q1 represent 25 percentile and Q3 represent 75 percentile. And the minimum value you can see 18 and the maximum value is 79 in the age column. So basically it tells that the age is distributed between 10 to 80 years. Then the second is gender distribution. And you can see that in the data set, the gender distribution are equally distributed. The genders are equally distributed, 50-50%. Then comes age group distribution. So as you can see from the bar chart that the chances of disease or being patient is skewed towards older age group, as it is common. The young people does not have such the young has little chances of being patient. Then comes symptom analysis. So top 10 symptoms are, we can see that here we have the graph where we have 8 symptoms, and you can see that symptom frequency are closely, they are not no single symptoms are dominating, all are similar to ranging from 697 to 773. Then comes diagnosis distribution where we have made for disease. You can see that in the data set, it is clearly imbalanced as non-disease cases are dominating, which we can see it is approx 1167. And if we see the clinical data, then pneumonia is least and bronchitis is most. Then comes a severity distribution. So you can see as them many of the cases are healthy, so mild cases dominates here, and then comes moderate severity, and the severity case is very less. Then I have plot critical vitals, which tells about how much critical condition is there. So you can see that most patients lie between 1 to 2 abnormal vital signs and very few in 4. Then I have plot for pie chart for the treatment plan distribution, how to treat, and you can see majority treatment are rest and fluids are given, and the chances of hospitalization is very low as compared to rest and fluids and giving medication. Then at here I have plot a box plot which will give us the understanding of the distribution of numerical values, and you can see here heart rate mean value is 89 approx, and it deviates between 75 to 104 mainly. And you can similarly see the body temperature. All numerical columns has been plot using box plot here. Then the second EDA part is our bivariate analysis, where we use two features to plot the graph. So our first graph is of age groups and number of cases and the diagnosis. So we have taken age group and diagnosis, and you can see that elderly have more cases of being as a patient. So you can see elderly individuals have the highest overall, and flu and bronchitis are relatively common in middle age. You can see bronchitis and in middle age. Then comes severity by diagnosis. So you can see from this graph that healthy and cold comes under mild severity, and the pneumonia and bronchitis comes under severe cases, and flu is like moderate case here. So this diagram represent that. I have also write insights here. Then comes a gender versus diagnosis, and here we have plot and diagnosis of each diseases with the gender distribution. And you can see that the distribution of both male and female have a similar pattern. They are approximately equal. So there we can not say that for this particular gender, the occurrence of particular disease is more from this graph. Then comes heart rate distribution. So it is a violin plot in which on the x-axis I have the diagnosis, and on the left axis we have the heart rates. And you can see in pneumonia our heart rate is very high. And violin graph also show the distribution of values, so you can see how uniformly distributed it is. Then comes temperature distribution by severity. So you can see severity here. There are three categories: mild, moderate, and severe. And you can see body temperature is very high in moderate case, and in mild case it is less. Our body temperature is approximately to normal condition. And in severe cases you can see the fluctuations of the temperatures, and it is more than the mild case. Then comes the other graph, that is a diagnosis of with severity. I have drawn the sunburst graph where you can see that healthy and cold comes under mild conditions, which is represented by this, and the moderate conditions, flu comes under moderate conditions, and bronchitis and pneumonia comes under severe conditions. So this graph represents that. Then comes multivariate analysis, where we take more than three columns and three features. So basically on one axis, and there on one axis there is a particular column, and we represent the third feature with the help of color or sizes. So from this graph, I think it is not visible. It has clustered a lot due to parameters I have given the size. And from here we can see that if the age is higher, 80 approx, then the heart rate, if it is 60, it is a normal case. You can see here healthy case. But if you are young, let's say 20 to 30 years, if your heart rate is approx 60, then it can be a bronchitis or a severe case. So the graph represent that. Then here we make a graph taking three features, that is temperature, oxygen saturation on on x-axis there is body temperature, on y-axis there is oxygen saturation, and the dots colors represent severity. So we are representing three features. So as you can see that if oxygen saturation level is below 94, then it's a severe cases. And then here we have plotted a 3D scatter plot, but we cannot analyze anything as it is very clustered. But we can see some patterns that if heart rate is less, then you can see that it's a chance of flu. When heart rate and age is less, age is approx 60 and heart rate is approx 110, you can see it's a flu case. So it is a 3D cluster plot. Then comes a box plot, like which is the a mild case, moderate case, and severe case. And you can see in heart rate, severity,
Wait
moderate.
a minute, Mars. Wait a
Yes.
minute. Your screen is not visible. I guess Akin's started sharing his present, like his screen. You will need to reshare it because in between, I just your screen was not visible. You just share your screen up once.
Okay, ma'am. From where I have to continue, ma'am?
Just a moment. Just share your screen. The last chart that you are telling after the 3D plot from there.
Yes, ma'am. Risk factor. Yes, ma'am. Box plot.
Yes. Yeah. Just
So
start it
basically,
over here. Yeah.
okay. So here we have created a box plot, and it is a multivariate analysis because we have severity on x-axis, and we have taken various columns to see the distributions of datas. So you can see that heart rate in severe cases are more And you can see in each case, just such as in temperature, you can see in moderate the temperature is higher, and in severe case also the temperature is more than the normal one. Then comes the saturation level, O2 saturation level, and we all know that in severe cases our O2 saturation level comes below, very low. So you can see here from this graph it is visible directly. Then comes systolic and diastolic pressure, and it is approximately same. Then comes the last graph where we have represent in the form of pivot table, where we have on x-axis the severity cases, and on left axis we have diagnosis cases, and on the right side it is representing the heart rate. So you can see if we have pneumonia, it is under severe case, and our heart rate is maximum at this time. And the second is the temperature, in which we can also see that in pneumonia and in flu cases we have the temperature highest 39.11, 39. Thank you, and this is at the last I have summarized all the things which I have told you in this presentation. Thank you, ma'am. Hello, ma'am.
Yeah, I am there actually, unable to switch on my mic. Yeah, it's okay, Mas. Fine. So the presentation that you did was pretty much good, and also the AD analysis that were quite appropriate. So you don't have to change anything. It covered most of the stuff to take care of. So it was pretty much good, Mas. So you can just directly submit your project and share it in the mail. Okay?
Okay, I have to just upload the Google Colab file.
Yes, you have to upload the Google Colab file and you need to just take it down to the GitHub, upload it in GitHub, and share the GitHub repository in the mail as well.
Okay, okay, ma'am.
Okay, so it's a great try from your end, Mas. It looked like it accurately taken all of the features of your data set to for the analysis. So this is how an exact ED analysis should be taken care of. Great effort, Mas.
Thank you, ma'am. Basically, I have
Okay.
just followed your steps which you have told
Okay.
turn. Yes, ma'am.
Yeah, that I can see. You have included all the steps in the like that I have told in the template. You have followed all of the steps. That's a great thing to catch on. Like all of it there, but you have taken it seriously and put it all in the project. That's a great thing.
Okay, ma'am. Yes.
Okay, so you
Okay.
can stop sharing. You can just go down and put submit your project up in the mail. Along with that, just as of now, just submit the fill the Google form that I have already shared in. Okay,
Okay, ma'am. Thank you, ma'am.
yeah. Okay, fine. Can you just copy the Google form link so that because we will be just ending the session now only, so you don't miss that out. Just copy, just open that URL so that you have that open in another tab of your file. You can stop sharing and just open that URL so that you can fill it later also because we'll be ending today's session now, right?
Okay, ma'am.
Okay, fine. Okay, guys, so we'll just wrap this session up today. So whoever is remaining, they need to present it tomorrow. So keep a note of this. This presentation is very important for the evaluation purpose. So you just go ahead, whoever is left, just need to present it in tomorrow's session. Okay, hope I have made myself clear. Then we can wrap up the session. Bye, guys.
Yes, ma'am.
Yeah.
Bye.
Bye. Bye, everyone. Bye.